Good afternoon and welcome to the afternoon briefing, where we're going to be looking at, pardon the terrible pun, we're going to be looking at reflections on cool cities. This session is really exciting. We're bringing together three of the top experts in the country and the world on cool roof technology and the really critical role that it's going to play in terms of not only keeping our homes cool, but also mitigating heat island effects. So without further ado, I'm going to pass straight on to our first speaker, who I am delighted is joining us again, Dian Grueneich, who joined us at the 2010 Energy Efficiency Conference, and we're really delighted to have her back here again. Dian has been an international leader in energy efficiency for over 45 years. She was formerly one of the Californian commissioners for the Public Utility Commission, the California regulatory body for public utilities, and is a renowned figure in the energy efficiency community, and has been at Stanford University, where she was her alma mater, and she is now one of the senior figures there leading the charge on energy and energy efficiency for the new generation. Without further ado, I'm going to pass on to one of my favorite speakers of all time, Dian.
Thank you so much to everyone. So I am speaking today in my role as a board member of an organization called the Global Cool Cities Alliance, or GCCA. It started about a decade ago. It was launched out of a national lab here in Berkeley, California by Art Rosenfeld, who many of you may know or had the honor to work with. He's known as essentially the founder of the energy efficiency industry. So GCCA, since its founding, has grown a great deal. It works with the United States Department of Energy, the United States State Department, the Clean Energy Ministerial, the Asia Pacific Economic Corporation, or APEC, and the International Finance Corporation of the World Bank. Among its activities is that it co-leads the Cool Cities Network with the C40, and that's about 40 cities around the world who are embarked upon cool city mitigation strategies. And I'm delighted that two cities here in Australia, Sydney and Melbourne, are part of that network. It's also standing up what is called the Million Cool Roofs Challenge, which is working at 10 countries around the world to start local markets for urban cooling. So you can see that effort is denoted on this slide by the yellow dots. So how do cool roofs work? I'll give an overview, but believe me, my two other panelists are deep in the details of this and will certainly provide more information. This is looking at an example where you're assuming 37 degrees Celsius and 99 degrees Fahrenheit. And under a typical black roof, that you have most of the, when the sunlight hits the black roof, large amounts of the heat goes to heating the atmosphere and the city itself, the surrounding area. Only 5% is reflected, and almost the same amount, about 4.5%, actually goes in and heats the building. In contrast, when we have a cool roof, you have the majority of the heat being reflected, about 80%, and only 1.5% actually heats the building. And also useful, only about 8% heats the city, with about 10% heating the atmosphere. So you can see the very stark difference of what happens within the building and the atmosphere when you have a cool roof versus a traditional dark roof. The benefits are really multiple, that you can have up to 20% cooling energy savings on average, but you have health benefits by reduced heat deaths, reduced visits to emergency rooms. Because you're not using as much air conditioning, you have reductions in your peak demand, which can lead to having to have less transmission. And you have efficiency gains and lower temperatures, which can reduce ozones. So when you collectively take into account all of these benefits, cool surfaces deliver benefits worth about 12 times their cost, which is why I and GCCA are really excited to be part of this international effort. So there is a lot going on around the world, and I'll just point out a couple things in Australia, and again, I'm sure we'll talk about it more, that some studies have been done. If all the roofs in Sydney would convert to cool roofs to reduce the average urban heat island, it could be a reduction of 0.6 degrees Celsius. And then if you added in cool pavements and trees, it could be 1.3 degrees Celsius. Sydney's climate is expected to heat up by 0.7 degrees Celsius by 2030. So if there were a massive undertaking on cool roofs, we could actually delay the impacts of this heating by almost a decade. And similarly with Melbourne, if you converted about 60% of the roofs to cool roofs, this would reduce the average urban heat island effect by about 0.5 degrees Celsius and up to 0.82 degrees with vegetation. So my takeaway that I want to leave with you on this is that we have the technology. We really have lowered the cost dramatically. There are multiple benefits, but what it means in terms of addressing and mitigating climate change is enormous. And that's why I thank everyone for letting us have the panel at this conference. So I'm just going to close with, we at GCCA would love to collaborate with any of you in Australia. A couple things listed here: knowledge exchange with local governments about, what are the techniques for this? What are some of the research projects that can be done? With APEC, we're working on cool roof testing, a standard harmonization effort. It would be great to involve Australia. And then one exciting new effort that we're launching is what's called the Cool Roadways Partnership, where we're around the world trying to set up demonstrations that really help us understand cool pavement technologies and bring down their costs. So for anyone who's watching, who's interested, please feel free to reach out to contact me. I also have listed the contact information for GCCA's Executive Director, Kurt Schickman. Thank you very much.
Thank you for that. That was an extraordinary presentation. One of the bits I was most surprised about from that is actually the city benefit from it. So I'd understood the benefit of cool roofs for buildings, and I thought that there would be a little bit of a flow on there, but I was quite surprised to see that actually the benefits for their urban heat island are substantially larger, actually. Absolutely fantastic. Thank you so much for that. I'm going to now pass on to our next speaker, who is the fantastic Professor Matt Santamouris, who's the Scientia Distinguished Professor, University of New South Wales. Now, Matt has a list of universities that he's been a professor at that is quite astonishing. So I'm going to keep it relatively short and say he's currently the Anita Lawrence Professor of High Performance Architecture in the University of New South Wales in Australia, but he's also been a professor in the past in Athens, University of Cyprus, London, Tokyo, Bolzano, Grueneich, Singapore. So you name it, he's probably been a professor there. Matt, passing on to you.
Thank you so much. Urban heat island and urban overheating is the most documented phenomenon of climatic change. We have data documenting the magnitude of urban heat island in more than 450 cities around the world. The average magnitude of urban heat island in Asia and in Australia is around 5.5 degrees, as you can see in this slide. But for example, in Sydney, it may, let's say, exceed 8 or 9 degrees during the summer period. And the difference between, let's say, the western and the eastern part of the city may be up to 9 degrees during the summer period. But urban overheating is not just the increase of the temperature, it has to do also with longer hot spells. And you see, for example, the increase of the hot spells above, let's say, 37 or 27 or 30 degrees during the last 100 years. And you can understand how really the climate has changed in Australia during, let's say, the last 50 to 100 years. In Sydney, this is very clear. Once we calculate the cooling demand of buildings in the western and the eastern part of the city, you can understand that in the northeastern part of Sydney, the cooling demand because of the urban overheating and the urban heat island is to about 3 times higher than in the coastal area of the city. It's not just that. Urban overheating has a very serious impact on peak electricity demand, but also on health. This is a map of the heat-related mortality in 2019 in Sydney, real data that shows that during the summer period, heat-related mortality in the northwestern part of the Sydney, which is really overheated, was almost 3 times higher during heat waves than, let's say, in the eastern part of the city. So actually, the impact of urban overheating is very well documented. And the main question is if we really were able to counterbalance the problem of urban overheating. The answer is yes. And we can do it because first we have developed very advanced monitoring techniques that can really give us specific information on the characteristics of the overheating. We have to start from there. You see it here, for example, the thermal mapping of Alice Springs in Australia with a resolution of 2 centimeters by 2 centimeters. So we can really know where we have to intervene and how we can intervene. The second important question is if we have technology really to decrease the temperature of our cities. During the last 30 years, there is a very intense research that has really resulted in the development of very advanced technologies, especially materials technologies, starting from simple white, let's say, materials, up to very advanced and sophisticated photonic materials that may reach subabyant temperatures. These technologies, which are available commercially, have been applied in more than, let's say, 450 large-scale mitigation projects all around the world, and we have tremendous results. What will happen, next one please, if these technologies and special cool roofs and cool pavements are applied in Sydney? We have simulated the impact of cool technologies in the Sydney area, and as you can see from the two slides, the use of cool technologies in Sydney may decrease the peak ambient temperature during the summer period up to 1.5 degrees. At the same time, may decrease the cooling load up to 30 to 35 degrees and also decrease the heat-related mortality up to 40%. Which is the potential of heat mitigation technologies? Some years ago, we started with something that was really, let's say, simple. And gradually we moved to very, let's say, advanced technologies like photonic, thermochromic technologies, and let's say daytime mitigation, daytime radiative cooling. And actually, the result of more than 450, let's say, large-scale mitigation projects all around the world, shown that we are able to decrease the peak, let's say, temperature in cities up to 2.53 degrees. We expect that in the next 5 years, with the development and the use of the new technologies, we may be able to decrease temperatures up to 4 degrees. So there is a major challenge about our future. This is a map that shows really where we are in Sydney and what will happen really if we don't have a proactive, let's say, policy. We are in the area where I saw the circle. And in case that we don't apply mitigation technologies in Sydney, we move towards, you see the right part, and by, let's say, 2050, temperature in Sydney may increase up to 5 or 6 degrees. On the contrary, once mitigation technologies are used and a proactive agenda is adopted, we may decrease temperature of Sydney up to 2.5 degrees, the left part of, let's say, the graph. This is very important, let's say, in terms of energy consumption. In the upper part of the slide, you see in yellow the heating demand and in red the cooling demand of a residential building in Sydney. This is what is happening today. If we don't have, let's say, any proactive agenda, no mitigation, by 2050, the cooling demand will increase by 3 times and the heating demand will stay almost the same. On the contrary, once we are using and we apply mitigation techniques, the cooling demand may decrease by 40% and the heating demand by, let's say, 20%. But the most important is that once we apply at the same time mitigation and adaptation techniques, better buildings, we are able to decrease with the actual technology the cooling demand by 90% and the heating demand by 85%. So I think that it is obvious that actually urban overheating increases the temperature of our cities in average by 5 degrees, but in sometimes up to 10 degrees. This has a tremendous impact on the energy consumption of buildings, up to 100, 200%, 300% higher energy consumption. It has a tremendous impact on mortality and heat-related issues, and also it increases tremendously the peak electricity demand. This is what is happening actually. But because of the very important, let's say, technology and the very important research that has been carried out and the actual technology, we are able to decrease the temperature of our cities up to 3 degrees. We expect that in the near future, we may be able to decrease temperature up to 4 or 5 degrees, decrease the energy consumption of buildings up to 70, 80%, decrease heat-related mortality by 40 to 50%, and also the peak electricity demand by 20 or to 30%. Thank you very much.
Matt, thank you so much for that. That was it was lucky I was muted there because I kept on the sharp intakes of breath when I was looking at some of those charts. And I think really what you highlighted there was not only the scale of the problem and the scale of solution, but the really important social elements of this, because for anybody who's in Australia, you know, the economic divide between the west of the city and the center of the city is quite extraordinary, and seeing those impacts is quite stark. Finally, I'm going to turn to Rex Lehman, who's the CEO of SkyCool, and it's a company that specializes in cool roof technology and has really been leading the charge, I guess, in the debate in Australia for the last 20 years. And I have to say, this is the first time I've really seen from this session just actually the enormity of the issue. Rex, we've had conversations about this many times, but this has been a very stark session just about how serious this issue is. So I'm passing on to you to give your presentation.
Thank you, Rob. Okay, following pretty much on what Dian and Matt were saying, here's a small example of the heating effect in Sydney, which is happening because the International Energy Association is warning that there's going to be a massive increase, not just in the heating, but the demand for cooling is going to have a major impact in what we're talking about. Look at this little example here. Western Sydney, out near Prospect Dam, you'll notice that I've just highlighted one little spot to show you what the source of that heat is. And it's those roofs, it's those industrial roofs that you can see in the expanded picture. So what would be fantastic would be able to address that problem without increasing the demand for global cooling mechanically. So the problem is that mechanical cooling, insulation, fans and vents, in terms of a building by building process, they're only addressing the heat after it has become the problem. So the key is to look at how can we solve the problem before it even starts, before we have to turn on our air conditioning, before we have to turn on any other mechanical or electrical draw. Why don't we treat the problem right at its very cause? Or source. This is where cool roof technology comes in a very individual as well as a city-wide and a nationwide aspect. This is some measurements that we've taken through looking at the energy use that is saved through the use of cool roof technology. In particular, this is all our case, although the measurements were taken by the clients. I want you to look at the energy reduction in the HVAC, that's the air conditioning plants, is up around, it varies from 30 to 50% when you isolate the plant. And now all of these instances here, the energy has been independently measured on the plant itself by sub-metering. We come to this national average, which is given us here from the product that we've been talking about, and we're looking at around about a 42% reduction on those types of buildings. And these are all buildings that are wide span and roof dominated, as opposed to a tall city block. So there's a difference that's going on here. So in these wide span buildings that relate to that little picture I showed you near Prospect Dam, we've been able to measure a rough average of 62 kilowatt hours per square meter per annum savings. And we did that with our product, SkyCool, as we've called it, trying to saying we're using the sky to do the cooling, which is in fact what we're doing, rather than, as I say, mechanical plant. That picture there is actually a picture of Perth Airport. I like it because it's the only dramatic picture I could find of a roof. Most roofs are very boring to look at. And Dian went through this very well already, but to put a few metrics to it in relation to the SkyCool product, we're looking at around about a 90% direct reflectance of the solar radiation, and also we're looking at an emissivity property. Now, the interesting thing about that emissivity is that it radiates through this sky window. That's 8 to 13 microns, which means that we're not heating the nearby air. So you get a multiplicity of benefits. You get removal of the solar radiation coming in, and you get the cooling of the building and of the surrounding air. So we're cooling the entire environment associated to that building. UTS, that's Professor Jeff Smith at UTS, has examined this product on several occasions. In a report in 2007, he said that around 650 watt hours per square meter of roof on a clear sky is quite achievable. This is the picture that actually, Diane, you also used, and I'll put a few numbers on it now. You'll notice that on the left is a standard building. This is halfway through the coating of the St. Mary's shopping mall. About 17,000 meters on that building, and a standard roof was reaching about 63 degrees, which is very, very typical on about a 28-degree day. And most people don't realize that, and Rob, as you said in your introduction, we fly over Sydney, we look down and we see all of these dark roofs, and we don't realize just how hot they really do get. And that heat is radiated down into the building. And of course, once we coat it with SkyCool, that measured temperature with a FLIR camera showed that that roof was at 24 degrees under direct sunlight. And that was actually about 4 degrees cooler than ambient. So I think that's a fairly remarkable result, and has been repeated many, many times. Just a couple of examples of people that have used it. This is the Airport Council International. They did a case study on the use of SkyCool. Amongst many things they said in there, they said, as you can read, over an 18-month period, the SkyCool paint has helped to save more than 40,000 tons of carbon dioxide through the reduction in the air conditioning use. Now that's a remarkable number. I think it's a remarkable figure because it shows not only are we cooling the environment, but we're reducing the demand for electricity, no matter how you generate it. Now in Sydney, most of our electricity, of course, is coal-fired generation, although that's gradually changing. But just to reduce electricity for any reason, or from any generator, is very, very important, I think. This is a case study put on by the Environment and Heritage on a DHL project that we did. They reckon they were saving about 390 megawatt hours a year, and that earned DHL well over 3,700 energy saving certificates, which is a New South Wales carbon trading factor. So they got a great result on that, and the motivation for them, their payback was in under 3 years. Just a quick snapshot of the various companies that have employed SkyCool, because it just gives you an idea with those sorts of names that you can see up there. It has been proven over the 20 years that we've been talking about. It was a long, tough road, but it's gradually starting to get traction now, and it really does encourage me for a whole lot of reasons, not just commercial, but lots of good reasons, because we can solve a problem so easily without creating another problem in the meantime, without having to, by looking for our cooling. So cool roofs equals cool cities, and in combination with that, the roads as well. But looking at this product, SkyCool, you can look at many, many more details on our website there. If you can read that, it says skycool.net.au. And it shows that that it produces all of this cooling, all of this vital cooling, especially in places like Australia. It saves the energy, it preserves your roof at the same time. Melbourne Airport, or one of our biggest clients, told us that they saved $1.5 to $3 million just in preserving an old roof that they had down there. So this is a combination of benefits, but the most important part is the cooling that we can help and introduce and bring it to cool cities. And the more we bring this out, I think we're going to find, as already been very adequately and very expertly explained by Matt and by Diane, we can bring a tremendous benefit. The world has an ability to heal itself if only we get out of the way and let it get on with it. Thank you.
Thank you so much for that, Rex. So And as I mentioned, like I've seen sort of Rex's, and we've had conversations many times about his technology, but it was really interesting to see for me from Dian and Matt, the actual synergistic benefits, the benefits well beyond the individual site, and the fact that this is actually an urban design issue. One building, it's great to see the savings there, but the impact that it has on the surrounding area and the impact of multiple buildings, pavements, and also roads and trees, and how those add together to make just a dramatic difference to, I almost say, the survivability of certain areas is quite extraordinary. So I'm going to start with a fairly non-technical question. One of the things I have to say about when I've seen this technology before is it literally, I mean, it's the problem for energy efficiency often is people say it's too good to be true. That's hard enough. With this stuff, it's like, really, a lick of paint is going to make that much of a difference to my cooling system, let alone to my city, is something that's quite hard to believe. And yet, the evidence is really uncontroversial. So it makes sense. You go to the Mediterranean, for example, and entire towns are painted bright white, and that's the traditional color. What is holding us back from doing this? Why do we still see so many dark colored roofs still being put in now, let alone retrofit?
First of all, I want to have a note of optimism here that we are in a radically different situation than we were 10 years ago. And so, yes, we see a lot of dark roofs, but it is changing. And you can think about there's two types of roofs. The flat roofs, we really have the technology there and the cost is comparable. And we've got lots of examples. So at least what we're finding in the United States is that our people who install the roofs, they're getting more and more knowledgeable about it. So they are offering it as a product because it's not a price premium and they can sell it on these benefits. And so we really have a market transformation that has occurred in many ways and is going to accelerate. It's the sloped roofs, I think, that are a little bit more difficult, and certainly my fellow experts here will probably talk about it, where you still do have a cost premium, but we're seeing the new technologies come in, and that's going to be coming down. But I would emphasize, again, it's a lot cultural, People need to understand this. They need to feel confidence. It's nice if their neighbor has it. But we are not where we were 10 years ago. And so I think it's slower than we'd all like, but we're certainly moving in the right direction.
And actually, one of the subject of neighbors, one of the things I've realized is, I should definitely be getting my roof whitened. And secondly, I'm on a strata title, and trying to get that past my body corporate is going to be quite the nightmare. It was hard enough to get double glazing in. Matt, what would you say is holding us back? Is it cultural?
Yeah, there is a tremendous progress during the last 10 years in terms of the technology development and also in terms of policy implementation. In specific areas of the world, and especially in Europe, this is extremely well understood. And I like really to stress the importance of, let's say, legislation. In most of the Southern European countries, now it is prohibited to have dark roofs. It is, let's say, mandatory for public buildings to have cool roofs. And also, there is specific legislation about pavements, etc. Why? Because, we had many demonstration projects, and we have seen, and everyone has understood, that really there are tremendous benefits. So for sure, we have to inform people. For sure, we have to inform developers. But at the same time, it is absolutely necessary to have the proper legislation. This may be applied in Australia because really this will help tremendously to decrease the temperature of the cities, improve thermal comfort indoors and outdoors, but also save lives and decrease the energy consumption and peak electricity demand. If really we don't have the proper legislation, because of the very important climatic change in Australia and the expected increase of the temperature, I'm afraid that some parts, of the country, especially, for example, very western part of the city, will be, let's say, abandoned by 2050. So we have completely to apply, mitigation technologies, and including cool roofs and including new technologies in order really to decrease the energy consumption, improve the quality of the living spaces, and save lives.
I believe it is very strongly cultural. We just got into the idea of having dark tiled roofs, or you see many new suburb being built, and they're dark grey. The roofs are dark grey to, in some cases, almost black. Although I do have to agree with Diane that things are changing, because we were asked about a suburb going up in Adelaide, and they wanted to know about cool roofs, and they said, how does it work? And I went through it, and then I said, well, a lot of people just don't like white. And then I went and searched Sydney, and I found a new suburb, and the whole large block of it had white roofs. So maybe it is just starting to change. Certainly industrial areas can make a major contribution to it. If as the one that we had a look at, if those large areas are done, they would be a nice, cool place to work, because the cool air just tumbles down off the roof. And in fact, some buildings we've had to do because it was just too hot to work in them. But I do think it is cultural. We haven't thought our way through. We haven't been in the situation that Matt was describing, and as you mentioned, Rob, in the Mediterranean, where necessity changes the culture. And we've sort of used our cheap electricity in times gone by to answer the problem by simply putting, whack in a new air conditioning unit. Well, that electricity price is no longer as cheap as it used to be, and it probably won't be forever. So necessity might help also drive a cultural change.
Great. Very quick question. Give me as short an answer as you can. If you had just one policy for cities and state governments to encourage cool roofs, what would it be?
Every city, especially in Australia, has a mitigation plan. These mitigation plans have to, let's say, be based on realistic assumptions, and should be based also on the use of the best possible technologies. We should not be based on myths. For example, let's say planting 5 million trees in New South Wales or in Sydney may decrease the temperature by 1 degree, 1.2 degrees, but at the same time may increase pollution, may increase water use, etc. So I think that our mitigation technologies and policies should be, let's say, adapted to reality, and at the same time, we need to have a lot of demonstration and real implementation.
Thank you. Rex?
I think we should learn from the lessons that the government did with solar PV, they did with LED lights, and provide some stimulus in there to look at this technology, partly because one of the big fears that this state government, and probably all of them do, is on energy security. And if they could put some funding into by some method, perhaps some stimulus in there to go to this technology, it would take away or help mitigate against the energy security that they're worried about, and achieve the same result they're looking for, a permanent, non-maintenance result.
Fantastic. And Diane?
Put it in the building codes. We've had it in California here in our codes for many years. As Matt said, you have it in Europe. Get it in the building codes. I'll add quickly 2 others. 2 is for government, lead by example. Put it on your buildings. Show it's real. And the 3rd is, again, government. When you're issuing an RFP or a tender, require that the respondents have something in which they talk about the efforts they're going to take to address heat. So those would be my policies. Fantastic.
Well, Diane, Matt, Rex, thank you so much for a really incredible session there. I've genuinely learned so much from today. As I said, I thought that cool roofs were a smart thing to do, but I'm now realizing that, look, it's a big social issue, and it's a big issue for making entire areas of cities livable. And that is something that we need to take very seriously beyond the individual benefits to any particular site. I'd like to thank you all for your time. I'd like to thank our audience for participating in today's session. And I'd like to close the session there. Thank you all for your just incredible contributions.